Okay, so how is everyone today? Good? So, shh, 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 shh. So, any questions before we get to business? Any questions? Okay. So last time we were talking about equations. And we're still talking about equations a little bit. So let's retread just a little bit of the ground that we covered last time. I could ask, well, how about this? 8 equal 8. Is that an equation? Yes. What's its value? True. How about 8 equal 3? Is that an equation? Yes. What's its value? False. And again, if you're feeling uncomfortable looking at the equation 8 equal to 3 and me telling you that yes, it's an equation, but its value is false, that's because there's two separate notions that I'm trying to cleanly separate in your head, and that is that there's the notion of a thing that is an equation, and furthermore, what is the value of an equation? It's going to be true or false. Yes, this is an equation. Its value is false. Good. 3. I could write, how about 3w minus 7 equal 1. Then, concerning this thing that I wrote, I could ask, is this equation true or false? And what's the correct way to respond to this request?
It can be true.
So yeah, I understand what you mean, but that's sort of like giving me the benefit of the doubt, right? That I intended something that was meaningful. But in fact, the way the question is stated, is this equation true or false? The question itself is wrong. It's not a correct question. In the same sense as the following question. So the Winter Olympics are on. Hopefully some of you watched some of it. And there's, the Olympic song. I used to know its name, but I can't remember it. Maybe it's called the Olympic Fanfare? I forgot. But it's the one that goes do 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 do. You know that one. So I have a question about that song. Does that song taste like an orange? The question is nonsense, isn't it?
In this class.
Yeah, in this class, it's nonsense. So, well, I'm telling you that this equation, 3w minus 7 equal 1, the question, is it true or false, is nonsense in the same way as asking, is the Olympic fanfare, does it the song Olympic fanfare, does it taste like an orange? Doesn't make any sense. Okay, so then here's a different question that is sensible. So this question is nonsense. Not nonsense. It has another N in it. Nonsense. For what W? Okay. Is the equation true for, say, W equal 2? Okay, that's a sensible question. So how do we confirm or deny? plug in 2. So 3 multiply 2, subtract 7, equal 1. Well, that'd be 6 minus 7 is negative 1, equal 1. So, that's false. So what's the answer to the question? Answer is no. Okay. How about is W equal, for example, 4 in the solution to the equation? Well, what does that mean?
Is 4 a solution to the equation?
Right.
What is that?
So that requires you to know the definition of the word solution. So what is the definition of solution? Right. So solution, this is just reminding you of what solution means. Solution is the set of all W's. W's just because we're dealing with W's. If it was Z's, it'd be Z's. Set of all W's for which the equation is true. Okay. So what I want you to see is that the two questions being posed in 3.2 and in 3.3 is the same question. I'm just saying it in a different way. So the way that you answer 3.3 is exactly the same way you answer 3.2. You just plug it in and check. Okay. Well, 3 multiply 4, subtract 1. No, subtract 7. Equal 1. Well, that'd be 12 minus 7 is 5, equal 1, which is false. So what's the answer to the question? So therefore the answer is no. W equal to 4 is not in the solution. All right. Now here's the question that probably you've been wanting me to ask. So I'll finally ask it. Please solve the equation. Well, how do we go about doing that? Right. We need to get the W by itself. Okay. So, well, we can move the 7 over. So 3W equal 8. So we move the 7 over by adding 7. We want to move the 3 over. How do we move the 3 over? By dividing, right? By 3. So W is 8/3. So now, this is how you answer the question. So when prompted, solve the equation. This is the answer. But I want to make sure that you understand the meaning of these words and how they're being used. Really, this is sort of like, well, it's really kind of like slang, to be honest with you. Solve the equation and then end with W equal 8/3. What this really means is that the solution is the set which contains the single value 8/3. That's what that really means. Because solution is a set that contains all the w's for which the equation is true. And what we're saying is that, well, you go back to the original equation right here at the top. At the top. If you were to go back to it and plug in w as 8/3 and simplify, well, you'd have an equation that's true. That's what it means. Okay. 4. Here's an equation. Y equal 2 times x minus 1. So now this equation is different from the previous in that there's 2 variables. And now I could ask, 4.1, I could ask, is the equation true at xy equal 3, 10? Well, how could we confirm or deny that? Right, just plug it in, except now there's a little bit more work to do because there's 2 variables, so some things are going to be plugged into the one kind and other things are going to be plugged into the other kind. So we're going to replace all the x's with 3's and all the y's with 10's. The result is 10 equal 2 multiply 3 subtract 1. And then the arithmetic on the right-hand side simplifies to 5, so that we have 10 equal 5, which is false. So what's the answer to the question? Okay, therefore the answer is no. The equation is not true at that point. I'll just say it out loud. I won't bother writing it. So this equation that I originally wrote down, is this equation true?
That's a bad question.
Right. It's a bad question. It's nonsense. Okay, you might, if you were on the street, right, and someone prompted you with this equation on the street and said, is this equation true or false? You might give them the benefit of the doubt and say, well, at what point are you considering? But, you know, if you were at if you were on this on the floor of the pedantry convention, then if someone said, is this true or false, then you'd have to say that's nonsense. Okay, so then how about is the point xy equal to 4, 2 in the graph of the equation? All right. Well, that requires you to know the definition of the word graph. We did talk about it last time, but, well, and I'll just mention again, that unless you were paying attention last time, or unless you had a really surprising high school math instructor, the definition of the word graph probably doesn't mean what you think it means. What is graph? Mm-hmm. So in particular, it's a set. It's a set. So graph is the set of all xy for which the equation is true. And notably, I'd like for you to observe that the definition of graph says nothing whatsoever about a picture. There's no kind of drawing, no mention of anything like that. A graph is a set. Now, it's just like the word the solution is a set. Solution is a set. Graph is a set. Gesundheit. And the only distinction between the word solution and graph is that, well, when the equation has one variable, you refer to the set as solutions, and when the equation has more than one variable, two in particular, you refer to that set as the graph. Yes?
On the graphing calculator, when you hit the graph button,
Uh-huh.
it draws a picture.
Right.
So the calculator responds to.
Well, so to be perfectly clear, there is a Greek. Is it Greek? I'm not sure. It's either Greek or Latin. I'm pretty sure it's Greek. Greek root. Graph. Graphos. Yeah. It means drawing, actually. And so as a result, in English, the word graph is very frequently associated with a drawing. Okay. No dispute with that. However, for mathematicians who write textbooks, math textbooks, and teach math classes, the definition of graph is a set. And when you're talking about a picture of a graph, that object is referred to as a plot. So when you're talking to a mathematician, graph means set. Drawing of graph is called plot. When you're talking to TI, Texas Instruments, graph means drawing. So here's the thing. You just got to keep it in mind. It's an unfortunate disagreement in terminology that's probably not going to be resolved anytime soon. When the textbook and when I say graph, it means set. And as far as mathematicians are concerned, Texas Instruments would do the world a service, a very good service, if they would stop referring to those devices as graphing calculators and call them what they are. Plotting calculators. That's what they are. That being said, the engineers at TI would have an equal and opposite thing to say about mathematicians. Did you have another question?
Yeah. I'm just confused because for example, where you have x and y equals 3 and 10,
Uh-huh.
I thought 3 and 10 was an interval, but that's a graph. 3, 10 is a
No,
graph.
3, 10 is a point. And we discussed this last time. But you weren't here, though.
Yeah, I was here.
You were? Okay.
Yeah, because I remember when you defined graph,
Mm-hmm.
but I don't remember. Well, can you do an example?
Yeah,
of
we'll keep going.
a graph?
We'll keep going. So what I want you to see is that these two questions, is the equation true at xy equal 310? And this question, is xy equal 42 in the graph of the equation? Those are the same question, asked in two different ways. So the way that we answer the question is the same way. You plug it in and check. So we'll substitute all of the x's with 4s and all of the y's with 2s. So the equation becomes 2 equal 2 multiply 4 subtract 1. So the equation is 2 equal 7. So 2 equals 7, that's false. So what's the answer to the question? So the answer is no. 4, 2 is not in the graph.
So the reason it's a plot is because it hasn't been confirmed that it is in the graph?
No. It's just a graph is a set. But when you want to look at a graph and you draw it, the drawing is called a plot.
And that's a point. 4 and 2 is a point.
Yeah, 4, 2.
Drawing is a plot.
Yeah, that's what I'm saying. So according to your definition, isn't 4-2 also a graph? You're calling it a point when he asks.
I think we'll make it clear in the next example.
Okay, that's fine.
So let's consider that equation. Let y equal 2 times x, subtract 1. So first, let's make a table. So -3, -2, -1, 0, 1, 2, 3. So what I'm requesting of you is that in each column I've provided an x value. So for example, in this column I provided the x value 2. I want you to provide for me the corresponding y value so that the equation would be true at that point, which is altogether sort of a convoluted way to say plug in the x and tell me what the y value is. So in the specific case of x is 2, that'd be 2 times 2 is 4, subtract 1 is 3. So 2, 3. So what y value do you get if you plug in x is 3? 5. What y value do you get if you plug in x is 1? 1. Now I'd like for you to observe that at least concerning these three, do you notice that they're counting up by 2s? 1, 3, 5. Well, that pattern is going to continue. So moving to the right, you go up by 2. So moving to the left, you go down by 2. Okay, so this would be -1, -3, -5, -7. Now, we haven't talked about it yet, but just as a matter of foreshadowing, things to think about, the reason why we're counting up by 2s in the end is because that's a 2 right there. If that were a 22, then we'd be counting up by 22 instead of 2. Okay, so now what I'm telling you is that concerning this table, each point is in the graph. What I'm telling you is that if you were to take that equation and plug in xy equal to 3, then what would be the equation's value? It'd be true. So the point 2, 3 is in the graph. Okay. So now let's make a plot, which is to say that every one of these points in the table is in the graph, and I want you to provide a drawing of all those points. Okay. Well, for example, this point 2, 3. How do we find the point 2, 3 on the axis? So from the origin, 2 right, 3 up. So that's the point 2, 3. Okay. So in the interest of time, I'll just plot the other ones real quick. So 3, 5, notably, is going to be over 1 and up 2. 1, 1 is down 2, left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. Blah, 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 blah. -3, -7 just falls off the bottom there. Okay. So now, here on the axis we have 6 points plotted. If, instead of plotting these 6 points, if we were to plot like 6 million points, then it would begin to look like this. Any question about this example so far? So now a separate question. 3. Visually indicate. Whether or not each point is in the graph. Okay. So, and I'll say confirm algebraically. Okay. So how about the point? We'll have 3 points. We'll do 4, 1. We'll do 0, 2, and 1.5, 2. 1.5. So since this is the first time that I'm asking you to do this task, I'll do the first one so that you can see what it is that I'm requesting. So the point 4,1, it says visually indicate whether or not the point is in the graph. So concerning the point 4,1, let's find it. So over 4 up 1, here it is. So there's the point 4,1. And the question is concerning that point we just plotted, is it in the plot that we made of the equation? It is not. So what's the answer to the question about whether or not 4,1 is in the graph? It is not in the graph. So our visual sense is telling us that 4,1 is not in the graph. The instructions say go on to confirm this algebraically. So what that means is that we're going to plug xy equal 4,1 into the equation. But now that we've looked at it, you should have an expectation about what will occur. When you plug 4,1 into the equation, what will be the result? I agree with both, right? It will be false. It will not be true. So let's witness that occur. So we'll plug in, we'll evaluate. All the y's get replaced with 4's, all the x's with 1's. So 4 equal 2 multiply 1, subtract 1. 4 equal 1, which is false. So does that agree with our expectation? It does. Now you please do the next 2. Yeah. 2 times x minus 1. Here, I'll write it right here.
I think we've got the first one backwards.
I might. It's entirely possible. What did I do? Yep, you're right. I have it backwards. I agree. Which is to say that I plugged in x's for y's and y's for x's. Okay. So it should be, so x's become 4's and y's become 1. Okay. So 1 equal 2 multiply 4, subtract 1, which would be 1 equals 7, which is false. I like it when a student can point out that I've made an error. It makes me feel more comfortable. Well, to know that you're paying attention and to know that when I inevitably do make an error, one of you will know and say. Instead of my fear, which is that I'd make an error, you'd copy it down and think it's right. Okay, so in the interest of time, so we'll plot the point 0, 2. So that means from the origin, proceed to the right 0 units and then up 2 units. So there's the point 0, 2. And then the question was, visually indicate whether each point is in the graph. So is it in the graph? It is not. And can someone in plain language say why it's not in the graph? It's not on that. It's not on the drawing there that we made. It's not on it. It's not on this line. Okay. So now we're going to confirm algebraically. Everywhere we see x, we'll write 0. Everywhere we see y, we'll write 2. So the statement is 2 equal 2 multiply 0 subtract 1. So the statement is, the equation is 2 equal negative 1, which of course is false. And that was our expectation. So now we'll plot the point 1.5, 2. So if that's 1 and that's 2, then that there is 1.5. And then 2 would be right here. Well, if that's 1.5, 2 there, 1.5, comma 2, is it in the graph? Yes. So yes, it's in the graph. Now, that being the case, that means you have an expectation about what should occur when you plug in x is 1.5 and y is 2. What is your expectation? The equation should be true. Okay, well, the equation is 2 equal 2 multiply 1.5 subtract 1. Well, 2 multiplied by 1.5 is 3. Subtract 1 is 2, which is true. So is that in agreement with our expectation? It is. So now, I could just select some arbitrary point here. I'm not pointing on any one of the lines. It's not a half. It's not anything. This is just some, who knows, right? We could get out a micrometer and measure it. And we get some really accurate measurement of where I'm pointing. But you should be able to tell me immediately, whatever we measure this with a micrometer and plug it into the equation, is the result going to be false or true? False. It's going to be false here because, well, we're not pointing at what we drew. Similarly, here is some other point right there. And again, we could measure it with a micrometer and get the coordinates very accurately and then plug it into the equation, and is the result going to be false or true? It's going to be true there. So what a graph is the set of all points where the equation is true. And a plot is a picture of all those points. You can think of a plot, all that it is you just take all the points that are in the graph and color them. That's what it is. Or, if you like, you could think of the pencil like a metal detector, right? And we're getting no detection over here, right? Silent. But then we go beep, beep, beep. Oh, we're hitting stuff that's in the graph. Beep. Beep. Is it clear? Good. Next. Definition of intercepts. There are two varieties. So given an equation in two variables, x and y. X-intercept is any point in the graph with y equals 0, and 2, a y-intercept is any point in the graph with x equals 0. So what I want to point out is that concerning the language, an x-intercept is when y is 0, and a y-intercept is when x is 0. Well, the reason why that's the case is that in an abstract way, the plane consists of two axes, and they don't usually have names other than numbering them, the first and the second axis. But because we're talking about an equation in two variables, and because the variables are x and y, that means that we're going to use the usual names for one of the usual names for the axes. So because we're talking about an equation in two variables x and y, what's the usual name for this one? The x-axis. And the other one is the y-axis. But do remember that if we were talking about an equation in variables p and q, one of them would be the p-axis and the other the q-axis. Now, concerning the y-axis, where does the y-axis have its 0? Right there at the origin, right? That's where the y value is 0. Okay, similarly, concerning the x-axis, where does the x-axis have its 0? At the origin, right? So things are so arranged so that the zeros of each axis occurs at the same point on the plane. Well, so that's the point 0, 0. Suppose we move to the right one position. Then what point am I pointing at? 1, 0. And then 3, 0, 4, 0, 5, 0, etc. Negative 1, 0, negative 2, 0, etc. Okay. What I want you to observe is that if you're pointing to any point that is on the x-axis, then what's the y-coordinate? 0. So the x-axis is algebraically where y is equal to 0. And similarly, analogously, what is the y-axis? Where x is 0. Okay. So if we draw some nice plot here, okay, so this is the plot of a graph of some equation in two variables. An x-intercept is any point where y is 0. So what is the name of the thing where y is 0? The x-axis, right? And so it's also an x-intercept. So the question is asking, concerning this nice red thingy I just drew here, is it touching the x-axis anywhere? It is. In two such anywheres, right? So here's one and here's the other. Those 2 points are x-intercepts. That's an x-intercept. That's an x-intercept. Where y is 0. Well, Are there any y-intercepts? Yes. Now it's asking, is there any place where you're touching the y-axis? Well, yes, right there. So for the second example, I'm going to draw a circle that is just resting on top of the x-axis. So it's just resting there. Does it have any x-intercepts? Yes. So the reason for me to bring up this specific example is I want to make sure you understand that an x-intercept is not required for you to cross. Touching is all that's necessary. Does this have any y-intercepts? No y-intercepts. And if we were to take this circle and pick it up even just a little bit, then it would have no intercepts of any kind. And that'd be a perfectly legitimate situation. And if we were to take this and turn it sideways, then it'd have a y-intercept and not an x-intercept, which would be just as legitimate. Any question about this? Okay. So I could again say let y equal 2 multiply x subtract 1, and I could request for you to find the intercepts. But now we're going to do it without the aid of a picture. It's going to be purely algebraic exercise. Well, let's find the x-intercepts. What is the algebraic condition for an x-intercept? Where y is 0. As a result, what we should do is take this equation and plug in y is 0 and then figure out what x is. So 0 equal 2 multiply x subtract 1. We can move the 1 to the other side. We could move the 2 to the other side. And then many students like for the variable to be on the left side, so I'll oblige you. And then I'll ask, so what's the x-intercept? 1/2 0. So notably, this is not the x-intercept, because look at the previous page. An x-intercept is any point in the graph. A point has 2 coordinates, right? It has the structure a comma b. So this is not an intercept. The intercept is 1/2, 0. That's the intercept. And that may seem like a minor thing, but it's not, because they're 2 totally different kinds of things. It would be like if you were on the street and I found you, and you said, "Oh, I'm so starving, and I could really use a banana right now." And I say, "Oh, I have a banana." And then I reach into my pocket and get out a picture of a banana and hand it to you. It's not going to work, is it? It's not the kind of thing that you were requesting. Okay. Finally, what's the algebraic condition for a y-intercept where x is 0? So we'll take all of the x's and replace them with zeros. So y equal 2 multiply 0 subtract 1. So y equal -1. So what's the y-intercept?
0.
Very good. So last thing before we get to the quiz is, let's look. Didn't we plot that equation 2 pages ago? We did. So the point, we're saying that 1/2 0 is the x-intercept? Well, there's the point half zero right there. So in the first place, is it in the graph? It is. Is it on the x-axis? It is. So it's an x-intercept. And the point 0, -1. Well, there's the point 0, -1. Is it in the graph? Yes. Is it on the y-axis? Yes. So it's a y-intercept. Good. So please put away your things. It's time for a quiz.